Today I will show you how to use a Agilent Technologies oscilloscope, for example DS05052A. So this is a simple oscilloscope. So it has a 2-channel with one external with an external trigger. So let's see first. Switch it on, this oscilloscope. So to switch it on, so this is the button one has to press. So as soon as you press the button, then the oscilloscope start to boot. So you see the Agilent technologies are coming, and so then it shows different things. So for example, if you want to change the language, then you can do by there are many languages you can choose. For example, you can choose English, French, German, or Japanese, or Spanish, and etc. So let's choose for the time being the English, because it is I'm demonstrating in English. Okay, so what you can see, there are many knobs and many buttons are there. So, and this is a window and the different scales you can choose. So what I will do today, I will essentially connect this oscilloscope with a Stanford research system model DS340 15 megahertz synthesized function generator, because this I will use to show different waves and how you can actually see or the measure different waves and its corresponding different parameters. So let's switch it on. This Stanford research systems function generator, or the frequency generator, the function generator. So essentially first I have chosen a function which is actually a sine wave and with a frequency of 0.1 megahertz, and this is basically my output, and this output through this VNC cable I first connect to a X channel of the oscilloscope. Yeah, so this is the X channel, the channel 1 X channel oscilloscope I have connected. Now let's see. So as you can see, we are actually sending a sine wave of frequency of 0.1 megahertz, but you see our oscilloscope essentially do not show anything. So let's see first to quickly visualize what is actually coming to the oscilloscope. It makes sense to press the button auto scale. Yeah, so you see, as soon as I press the button auto scale, then immediately I see a sine wave. Yeah, and the color of the sine wave is essentially the yellow, which is actually corresponding this one channel or the X channel or these knobs. Yeah, you can increase or decrease the intensity of the oscilloscope by using this knob. So I don't want to use too much high intensity, but let's see, this is the 50% of the intensity now currently I'm using, but it's better to use less intensity for the normal operation condition. Okay, now we see a beautiful sine wave. Now let's see how we actually, this is basically the X channel, and we can see this is the time axis and this is the amplitude. Yeah, so if you really want to change this time axis of waves many periods, you can use this button. Yeah, and if you really want to increase the amplitude, then you can so that increase the scales, you can use this button. Yeah, and this is for this direction of the scales you want to see. So I think this is okay. Now I want to show you how you can measure different parameters. Yeah, for these sine waves. So to do that, the very first quick thing you can do, just press the button, the quick measure. So if you press the button quick measures, then it shows some of the information here. Yeah, the first thing you can see, this is basically, it shows the frequency. Yeah, the frequency is actually 100 kilohertz. Yeah, so let's check what are the other things you can measure. So to do that, you have to press this button, and if you press this button, then you have different options. So press once more, and then now you can change by using this button, which parameter you want to estimate. For example, let's start with the beginning. Let's start to measure the amplitude of this wave. So now you see my amplitude has been selected. So now if you press this button, then it will show the measured amplitude, and your measured amplitude is 106.3 or 105.3 millivolt. Yeah. Now, for example, if you want to measure the frequency, yeah, if you measure the frequency, then you have to select the frequency here, yeah, and then as soon as you press it, then you see the frequency is 100 kilohertz. Okay, there are several other parameters. For example, you want to see the period. So if you really want to measure the period, then select the period and then measure period. Then immediately you see this is essentially 10 microseconds. This is basically the period of this sine wave. Yeah, so that's basically gives you the cursor, and this is basically the complete period of your sine wave. You can also make the measurements by manually. That means then you have to use this button of this cursor. Yeah, so this cursor button essentially gives you different ways of which part of the wave you want to select and how you want to measure. For example, if you see this button now, my x cursor is selected. Yeah, and then this is essentially x1. So if I press this button x1, then x1 is activated. Then you will see this cursor will move. Yeah. So for example, if you want to place the cursor here, so then the cursor is coming here. Now you want to now change the cursor position of this is the x2. This, then you have to press this one, and then your cursor, you can move it like that, and then it gives you the position of x2 is actually 2 microseconds, and this is the position of minus 2.68 microseconds, and then this gives you a difference. So similarly, you can also change the y cursor, and then you will see, for example, my y1 is selected. So y1 is essentially this things is moving, this cursor is moving. Yeah. Now if you want to change the y2, then this cursor is moving. Okay, so this way you can change different cursor position, and then you can estimate different values depending on your needs. Yeah. Okay, so far I was showing that how my X channel is behaving. Now if you want to connect it to see how your Y channel is doing, you just have to connect it to the Y channel, this VNC cable, but you see nothing. But if you make the auto scale immediately, then you will see the same sine wave is coming, but now the color of the sine wave is green, because this part of the oscilloscope is actually now connected. So essentially you can do the similar operation. You can make all the parameters, you can make all the estimation through as I showed also for the channel 1 of the X. But that, as I was telling, this is essentially time domain signal. So far I was showing. You can also go to the XY mode, so that means only the amplitude versus amplitude properties of the wave or the signal what you are sensing. Yeah. So now let's go back to our main thing. So this is the time domain axis, and then you see the time domain signal. Okay, so far I was showing if you have a sine wave, then how your oscilloscope are reflecting your sine wave depending on the function generator. So in this function generator, there are other waves you can also generate. For example, this is a square wave. Now I am generating from this with the same frequency of 1 megahertz. Now you see your square waves looks like this. Yeah. So similarly, you can make the quick measurements, for example, and then you want to see, for example, your period of the so measure period. You see this is the 10 microseconds. If you increase the scale, then you see basically this is actually a complete period of a square wave. Okay. Similarly, if like a sine wave, you can also measure all the properties, all the parameters of a square wave using the same principle. Now if you use this, for example, the triangular wave, this is a kind of triangular wave, this is then also similarly you can measure the period, or if you want to make the frequency, measure frequency, you can make it. You can go a little bit more further. For example, if you really want to make a kind of a sawtooth wave, this also possible. So this is the sawtooth function, and then you can see, for example, frequency, measure frequency 100 kilohertz, and then if you want to make a period and then measure period, you can see 10 microseconds. So okay, not only that, if you really want to see your noise values, that also can be reflected in your oscilloscope, and then coming back to your sine wave. So this is way the very simple thing. Now there are other options also. You can make a quick print of the information, or also you can make a save file, because this is you can also put an USB sticks there, and your oscilloscope can also be connected to the GPIB port and also the internet. So many things. So that means the remote operations are also possible with this beautiful oscilloscope. Okay, I hope this. Okay, one more thing. If sometimes if the triggering, if really difficult, is not automatically collecting the signal information, then one also has to adjust the trigger level, and that's external trigger one can also use for this purpose. So I think this is a very simple demonstration, and if you need further information, you can read the manuals and other sources. Thank you.